In a shooting game, you need to create a large number of bullet objects in a short time. And zombie objects, if frequently created and destroyed in the normal way, what problems will it cause? Like this. In the program, when a large number of objects are created in a short period of time, it can easily lead to memory shortage. This triggers GC, causing performance issues. For this question, it can be solved using object pooling techniques. This lesson, let's find out together. Object pool technology and implementation principle. Learn a skill. We need to understand the context of this technology. Then you need to know the basic concept of this technology, usage scenarios and advantages and disadvantages. And finally, it is necessary to understand the principle of its design and implementation. First of all, let's look at the background of the problems arising from object pooling technology. Object pool technology is related to memory management. Therefore, we must first understand the garbage collection mechanism. Inside Android, it's a 3-generation memory model. Recently assigned object will be stored in the young generation area. When this object, they're in this area for a certain amount of time, it will be moved to the old generation. Finally to the permanent generation area. Memory area at each level all have a fixed size. Since then, new objects have been assigned to this area. When the total size of these objects, when the threshold for this level of memory area is approaching, triggers GC operations. To make room for other new objects. Every time GC occurs, all threads are suspended. Time occupied by GC. It also depends on which generation it is. Each GC operation time of the young generation is the shortest. Old generation second. This memory model, in some cases, it can lead to frequent triggering of garbage collection. When a large number of objects are created, when released immediately within a short period of time. For example, bullet objects and zombie objects in the game are frequently created and destroyed. In this case, it is easy to cause garbage collection to be triggered frequently. Instantly generate a large number of objects, seriously occupy the memory area of the young generation. When the threshold is reached, when there is not enough space left, it also triggers GC. That's garbage collection, garbage collection. even if the objects allocated each time uses very little memory. But they stack on top of each other, increases the pressure on the heap stack. This triggers more other types of GC. This operation may affect the frame rate. And make users aware of performance issues. How to solve these kinds of questions. And thus object pooling was born. What is object pooling technology? So-called object pool. Just a pool. It contains the specified number of objects. During the code implementation, string a specified number of objects using a linked list. When we need to use it, remove objects directly from the pool. After use, return the object to the pool. This process, the caller is not required to create the object or destroy the object. Object pool. It is widely used in game development scenarios. For example, when making bullet shots, the bullet is twisted out with each shot. Such an object consumes memory resources. When the bullet hits the corresponding object, there is no need to display bullets on the screen. The time required for this process is often short, so it needs to be released again. Is that so? Create and make up objects repeatedly over a short period of time makes the program very inefficient and consume memory resources. So using an object pool, bullets are fired, get it from the object pool accordingly, an object. The bullet disappears from the screen, correspondingly return this object to the pool. Specifically, encounter these scenes. We should consider using an object pool. A resource-constrained situation. The CPU performance is not strong and the memory is tight. Garbage collection can have a significant impact. Wait for the case. Need to improve memory management efficiency. For example, requires a large number of short survival periods, objects with low initialization costs. Using an object pool, reduce memory allocation and redistribution costs. Reduce memory fragmentation. Objects are allocated at a constant rate. Garbage collection time gradually increases. Memory usage is increasing. Object allocation has an explosion period. Each burst causes a system delay. And there is a noticeable break in garbage collection. The initialization cost of two objects is very high. Or the object is too large. It's more complicated to build. So it seems. Some students will one-sidedly believe that object pooling is good, not bad. That's not true. Everything has two sides. Let's take a look at the advantages and disadvantages of object pools. The advantage of object pooling is that objects in the object pool can be reused. You can avoid frequent creation and destruction of objects in the heap. This in turn reduces the burden on the garbage collector. Reduce memory jitter. It is not necessary to repeatedly initialize the object state. For more time-consuming constructors, very suitable. The downside is that in a concurrent environment, multiple counties may need to acquire pool objects simultaneously. This in turn requires synchronization on the heap data structure. Or there is a blockage because of the competition. This kind of overhead, hundreds of times more expensive than creating and destroying objects. In addition, due to the limited number of objects in the pool, it is bound to become a scalability bottleneck. And finally, sometimes it is difficult to properly size the object pool. If it's too small, it doesn't work. If it is too large, it will account for excessive memory resources. After understanding the relevant knowledge of the object pool, how do we implement object pooling? Let's take a look at the design principle of the object pool. Object pooling is about requesting a large chunk of space from memory. Then, in this memory space, build an object. Take up a small piece of space. Get this small piece of space when using it. Return to the object pool when not in use. When you need to call, apply for space in the system again. Different types of object pools exist independently of each other. In this diagram, PU represents a pool of objects for storing repurposed objects. The first step is to initialize the object pool. The second step is to extract the object. The third step operation is to use the extracted object to complete some tasks. There's no need for the object pool to do anything. But it also means that the object will be rented for a period of time and cannot be loaned by other components during the lease period. The fourth step is to return. Form the return of the loaned object. This way, other rental requests can continue to be satisfied. As long as you understand the design principle of the object pool, it's not difficult to implement. Below, we use object-oriented programming ideas. Implement an object, OBS. Classes share common characteristics, a general term for the same class of things that act together. We will identify the common characteristics of the class, reduced to class member variables. Common behavior distilled into class occupants. Method. In the object pool class we want to design, crew variable has object pool capacity. Whether to allow automatic growth. That is, when all objects in the pool are fetched. Whether to allow the creation of new objects. Template to generate object. These are prefabricated questions. Complex object of the generated object. That is, the node to which the generated object is mounted. The following occupant methods should be provided. When there is an initialization object. Fetch object. Attention! Why not return the object method? Here we simplify the process. Just set an enable flag for all objects, variable. The initial value is false. Indicates that the object was not retrieved. Set the enable property of the object to TR after retrieval. That's it. Here they are. All objects in the object pool. We can use the list to store it. Therefore, according to the analysis just now, can be in the upspool class. Set these occupant variables. Next is the crew method. Initialize the object pool first. Where the parameter prefab represents the prefab of the generated object. Pull the mount to indicate the number of object pools. The default value is set to 20. Will grow says whether it grows automatically. That is, when the objects in the object pool, when the maximum number of settings is reached. Whether to allow regeneration into new objects. The default value indicates allow. Optional parameter. The parent object represents the generated object mount point. It's called a back-office question. In the method body, set parameters to member variables of the object pool. Then initialize the object pool. Generate objects from preforms in the loop body. This method can be completed later. And then it's done according to the preform. Methods for empowering object pool objects. First call the instance method to strengthen the object. Then determine whether the optional parameter parent object has a value. If there is value, then the attached node of the object after the strength is reduced, set as parent object. Simultaneously, set the local coordinates of the empowered object and local rotation value. And finally, set the object to not enabled. Just add it to the object pool and return it. So far, the object pool only needs one method to access the object. Get the logic of an object from the object pool is a convenience pool object. If there are unenabled objects in the object pool, then return directly after acquisition. If you do not return after the convenience is completed, indicates that there are no objects available in the object pool. At this time, whether to allow automatic growth according to the parameter settings, do the corresponding treatment. If the setting is to allow automatic growth, then return after generating a new object according to the prefab. Otherwise, you can only return undefined. We're done with the object pool. And finally, let's briefly review the content of this lesson. This lesson, we introduced to you the technical background of object pool technology, understood some basics of object pooling technology, advantages and disadvantages. Finally, its design principle is analyzed. In the next lesson, we will implement object pooling. And we're using object pools in our games. I hope you will review the content of this lesson after class. Simultaneously, preview the next lesson in advance.